Okay, so we will start once everyone came, then we will do with this stuff. Okay. So, what are the topics that we have discussed into the previous or before our examination? Your examination is there. We have ended our discussion with respect to the topic name is multiplexing. Okay, frequency division multiplexing, time division multiplexing, wavelength division multiplexing. Out of which time division multiplexing, there are few slides are remaining. But frequency division multiplexing and wavelength division multiplexing, that already we have discussed. Okay, so what is a time division multiplexing that actually we need to see in this one? So as just on a refreshment, time division multiplexing, it means like you are allocating a specific period of time for the specific channel. Let's say you are having a 4 channel. So how the multiplexing is going to be done? Let's say for 1 second, for the 0 to 1 second, first station will just give the data. Then in the 1 to 2 seconds, second station will give the data. Then second to third second, third station will give the data. Likewise, the frame is going to be generated depend on that station by station turn. So you can see there are a 1 0 1 0. So there are a first frame is generated as a B C D. Then you can say 1 0 0. So second frame will generate it. Then 1 0 1 1. It's generated. So it is having one timer circuit inside of that. And the timer circuit is set up with the one specific period of time duration. Let's take in 1 microsecond, 1 millisecond. So in that duration, it is allowed to speak only one station. Then it will change their counter to another station, then another station. Likewise, this loop is going to rotate. Likewise, the frame is going to be generated depend on that, whatever the station is going to speaking on their time duration. So likewise, time division multiplexing is going to be happen. So we are multiplexing time. We are multiplexing the different time data, okay, which is generated by the different station. It is going to be happen like this one. You can say what is interleaving and how this stuff is going to be happen. So as I have told you, there are a loop is there, and it is always required the synchronization between sender and receiver. Let's say you have started with the stuff of like whatever the transmitters are there, it is creating the frame with respect to 1 second of the time interval. Like 1 second, like first, second, third, first, second, third, and the time duration between this rotation is, let's say, 1 millisecond. So the same rotation, same time period must be followed at the receiver side. Then and then you can retrieve those data back. If it is not going to happen, then what happened? If it is not going to possible or such missynchronization are there, then which type of the issues is going to happen? Like it is assigned for some different station and it is reached to the another station. Due to that missynchronization or no synchronization stuff is there. So synchronization is required as well as whatever the time frame you are or whatever the time duration you are following, whatever the time interval you are following at the transmitter side, same time interval must be followed at the receiver side also. Then and then this stuff is going to be work fine. Okay. So we can say like that whenever we can say how the frame is going to be generated. So one thing that we need to keep over here in mind that let's consider you are having 100 byte per seconds are there. 100 byte per seconds are there. Whenever the frame is going to be generated of multiplex, it is going to be faster as a number of lines you have. You can say like that. You are having a 4 channel with you. So we can say all the 4 channel will participate as a one time slot in one frame generation. So the speed of the output frame is going to be 4 times faster than the actual data that you have given to them. You can say like that, let's say you are having a 32 kbps of the 4 channel you have. But whatever the output multiplex frame is there, it is multiplied by 4. So 32 multiplied by how much channels you are giving in a multiplexing, that much of the faster speed of the frame going to be generated. Now, why it is required to make it 4 times faster? आप सोचिए, like पहली सेकंड में आपने देखा कि 32 किलो बीट्स में यहाँ पे जस्ट एग्जांपल लेता हूँ, like we can take this example. it is says that your input must be transmitted as a 100 bytes per second. मतलब कि हर एक चैनल का 100 बाइट्स एक सेकंड में जाना चाहिए. यस दीक्षित. Okay. It is showing like that in every second the 100 bytes must be go for the each station. लेकिन आउटपुट में तो 4 स्टेशन कंबाइन हो रहे हैं. In output there are 4 stations are combined. So we can say what you need to look after the 1 second you will look. आप 1 सेकंड के बाद देखोगे जो आपका मल्टीप्लेक्स डेटा हो रहा है उसमें चारों के चारों स्टेशन होने चाहिए और चारों के चारों स्टेशन की जो स्पीड है वो भी फुलफिल होनी चाहिए. तो मैं ये कह सकता हूँ कि एक स्टेशन में से 100 बाइट्स पर सेकंड निकलेंगे तो चारों के चारों स्टेशन की कितनी होगी 400 बाइट्स पर सेकंड. It means ultimately whatever the output frame is there that I need to generate as a 4 times faster than your input. तभी जाके वो क्या होगा 100 मल्टीप्लाई बाय जितने स्टेशन उतना जो भी डेटा एक सेकंड में ट्रांसमीटर से निकलेगा वो सब मल्टीप्लेक्स होके चैनल में जाएगा अगर मैं उसको 4 टाइम मल्टीप्लाई नहीं करता. So whenever the output is going to be there, it is going to be multiplied by 4. Or in another term, we can say whatever the one frame generated. मैं हर एक को डेडिकेटेड एक टाइम स्पेस दे रहा हूं तो एक फ्रेम का ड्यूरेशन क्या होगा 1/100 बाइट्स पर सेकेंड. ठीक है. हर एक फ्रेम बताऊंगा उसको मैं 100 टाइम फास्ट 1/100 सेकेंड कर रहा हूं. उसका मतलब क्या होगा कि जो भी एक फ्रेम बनेगा उसकी स्पीड क्या होगी 1/100 बाइट सेकेंड. और ऐसी कितनी बाइट्स होगी मेरे पास इतनी कितनी फ्रेम होगी 100 फ्रेम्स आई हैव. एक फ्रेम का ड्यूरेशन 100 सेकेंड. Okay, and we can say that much of the 4 times I need to do that, so that much of the data is going to be combined with multiply by with that 4. समझ में आ रहा है नहीं or is it not with you? Done? पक्का? Means यहाँ पे देखा next slide में हम देखेंगे उसमें better पता चलेगा. We can say like this one, everyone is having a, I'm speaking it very loudly, just check your connection. Is it okay with everyone with this voice? Okay, chalo. So I can say over here that let's say there are 100 kbps speed is going to be there, and we can say the frame duration is whatever the output frame duration is going to be there, which is going to be 1 divided by 50,000 seconds. Overall one frame duration is going to be 20 microseconds. And how this all the stuff will came, it is come from this equation or from this particular question. Like there are a 400 kbps channel is there and it is time slot of 2 bits. So we are sending a 2 bit multiplex simultaneously and output is going to be 4 arbitrary bit. What is the frame rate? What is the frame duration? What is the beat rate? Likewise it is going to be calculated. Yes, Ranjan. बोलिए क्या डाउट है. You can please mute your mic. So we can say like that it is carrying we can say that arbitrary inputs as shown in this particular figure. Okay, it's particular in this figure. It is showing like that it is carries the 50,000 frames per second. Why? Because there are 100 kbps is there. So 100,000 is there, but you are sending a 2 bit each a time. So we can say there are 50,000 beats per second is there 100 divided by 2. Now what is the time duration? 1 divided by 50,000. So we can say 1 frame duration which is going to be a 20 microsecond. And the frame rate, output frame rate is as I have told you, हर एक में 100 kbps जा रहा है तो output कितना होगा 400 kbps multiply by that 4. So we can say there are a 400 kbps speed is there and there are a such 50,000 frame is going to be transmitted in a second. Okay, so these are the calculation you can do like that. So इतना overall duration है, वो duration को करने के लिए आप क्या करोगे? You can find out 1 divided by the duration. So frame duration you can get. Like एक frame के लिए कितना time लगेगा? Likewise. And हर एक frame में it's a 2 bit combination. So in each frame there are 8 bit is going to transmit it. Okay. These are the stuff we have. And obviously 8 bit in one frame, 50,000 frame. What is the rate? 8 multiplied by 50,000. So it's a 400,000. It's a 400 kbps speed we have. Directly we can get it from that equation also. एक फ्रेम में 8 बीट, ऐसी 50,000 फ्रेम, 50,000 फ्रेम multiply by 8. So we can say there is a 400,000 frame. 400,000 it means 400 kbps. That's the solution we have. If there are some slot like that, if some station is not speaking something, let's say there are empty slot are there. So when you are creating a such type of the frame, such type of the duration, whatever the empty slot are there, it is kept empty in the frame also. So to achieve the synchronization or not disturbing the synchronization problem, you must need to take the empty slot. अगर ये स्टेशन कुछ नहीं बोल रहा है तो उसका empty slot जाएगा, उसमें कुछ डेटा ही नहीं होगा, बाकी के जो है वो डेटा भेजेगा. So that also you need to fulfill whenever you are having such empty slot. Another biggest problem we can say, like sometimes it is possible, sometimes it is see it over here. Coming properly. Hello. Hello. Okay. Chaliye. Thank you for confirming. So what are the stuff is there? Like let's consider you are having some of the odd type of the data rate is there. So 3 station having a 40 kbps, like 2 station having the 20 kbps. So to fulfill the data rate, like whatever the input data rate is are there, which must be the common. तभी जाके वो multiply by 4 होगा ना. Like you are having 100, 100, 100, 100, then it's become a 400 kbps. ऐसा नहीं होगा कि one is 98 kbps, another is 92 kbps, and then combine. So that time division multiplexing is not possible with that. So somehow we need to make all the channel into the same data rate. But now if it is in not same data rate, then what are the solution for that? We can say like that. Let's say there are 2 channel of kbps we have. So ultimately we need to multiplex them first. So 20 kbps multiplex, so output is going to 20 multiplied by 2, 40 kbps. Then this 40 kbps participated with the rest of the 3 channels. And overall output will be 40 kbps multiplied by 4 channel. Output is a 160 kbps. So if such a mismatch is there in terms of the data rate, so you can use the cascaded multiplexer. Achieve that time division multiplexing principle. It is also going to be possible sometimes. Let's say there are a higher data rate is there. Like 3 channel is with the 25 kbps, one is with the double speed 50 kbps. So what you need to do, you need to put a such type of the data rate divider, or you need to further divide those data rate into the 2. So that's considered as a like, if you know the digital electronics, there are one device is there, there are one digital component there, which will actually divide your frequency by 2. Say the answer of that one. Which digital component will divide a frequency into 2? It is a D flip-flop. Whenever you give the clock into the D flip-flop, and the same input you will give it to the input D. D में होता है ना, D होता है, clock होता है, Q bar, D, clock, Q bar. These are the structure is there. So when you give the input in D as well as in the clock, the output frequency is going to be divided by 2. So such type of the intermediate device you will put and reduce your data rate into the 25 kbps. So one side is going over this one, rest of the like positive side pulse will go this side, negative go this side. So both sides you are dividing the data rate. So like 50 kbps convert to 25, and then such type of the 5 channel you have 25, 25, and 5. So what is output data rate? 25 multiplied by 5. Output is going to be 125 kbps. So in the frame, first 2 frame is just look for the first 50 kbps contribution, while rest of this yellow, orange, and green for the rest of them speed. It is sometimes there is odd, like it is not can be multiplied, not can be divided by 2, but some odd number are there. Let's say 46 kbps, but rest of the channel is in a 50 kbps. So what type of the block you need to put? You need to put the pulse stopping. So whatever the remaining 4 kbps are there, you are getting extra. You are generating some extra sequence generator, and you are adding such beat as a padding. Extra beat you are generating and make it to 50 kbps. So at that time, you required a pulse stuffing type of the block, which will generate an extra beat once your 46 kbps is going to over, and then it will match with the 50 kbps, and then multiplexing is going. So three things we have: either the channel is going to be in a higher data rate as compared to other, either it is into the lower as compared to other, or in any odd manner, 46, 23, 22. Then this type of the solution we have to match those data rates. That thing you need to keep it clear. Any doubt? Okay, chalo. So we can say there are framing beats are also going to be there. Now, what do you mean by framing beat, and what are the stuff related to that? So whenever we can say, what do you mean by framing beat? So we are creating a frame. We are creating the data like from first channel, second channel, third channel, and so on. But out of this, let's say 100, you are sending, let's say at the 150 mbps of the speed. But whatever the frame is going to be generated, actually we are transmitting those stuff into the network. हम उसको network में float करेंगे. So whatever the frame you have generated as a combine, you must give some name of them. It is like that. अब ऐसा कर सकते हो कि like let's consider in from the Marwadi. In the Marwadi, there are 50 professors are there. They are sending a letter to the various companies. वो अलग-अलग लोगों को लेटर भेज रहे हैं, 50 लेटर भेजे, लेकिन वो सब कंबाइन होके कहां से निकलेंगे? Is the address of Marwadi University. So we can say whatever the individual frame, 50 frame are there, it is combined into one packet. Give the name, it is all from Marwadi University, and give it to the agency. Then this agency will decide that where I need to carry forward this entire bucket. Okay, then it is reached to you. So likewise, that framing number is going to be given for each of the stuff. When we are going to discuss that analog base, such time division multiplexing, this framing is going to be useful. So there are a synchronization pattern. It will be say like that. Whatever the pattern is going to be, it's follow like 101, then again 101. Likewise, there are a synchronization pattern is there. So first packet is come with the 1, then second packet with the 0, then 1. If it is something mismatch between them, 1 0 1 1, 1 0 1 0, if such type of the stuff will come, it will quickly identify. Synchronization is not there, because after the 1 0 1, again I can say you start with the same frame 1 0 1. But if it is not came, then you can say like that there are something packet is just missed in between them, but there are some miscommunication, misynchronize. So it is just an example 1 0. It can be anything like 0 1 0, or we can say 1 1 1. Then we can say 0 0 0. Likewise, the pattern you are just identity you are giving. Like if in this pattern the all the 3 frames came, you can identify the synchronization. There are some examples there which is related to the digital hierarchy. As I have told you in a frequency division multiplexing, and we have discussed one particular example. Like let's say you are having a telephone company you have in a Rajkot, let's say the BSNL. So what BSNL, how the multiplexing is done at the BSNL? BSNL is just look for the main lines. Like it is look for, let's say there are only 8 lines are coming to the main center at the Jubilee Bar, the Jubilee Garden. In the Jubilee Garden, there are main BSNL offices there, head offices there. So over the head office, only 8 lines are coming. Now, what this 8 line are containing? It is containing the multiplex data of various areas. Like one line is coming from Palava Road, one line is coming from Dorsopur Ring Road, one line is coming from, let's say, Soratiyawadi, one line is coming from, let's say, another area. So likewise, this individual line coming from the major area of the city. And when you go to that area, again, it's get multiplexed. So whenever you go to the area, it will say like that on Palava Road, it is coming from the area of this society, this society, this society, and all those data going to combine to that particular line. So there are a digital hierarchy, frequency division multiplexing hierarchy are there. And why this hierarchy is required? If we are not doing this hierarchy, and if you say that in Rajkot there are 30,000 telephone customers are there, and if you are not using this hierarchy or multiplexing, then what happened? All those 30,000 cables, you need to make it reach to the central system at Jubilee. तो आप किसी भी कस्टमर को नया टेलीफोन लाइन देते हो तो आप अपने जुबेली गार्डन से लेके उधर तक एक लंबा वायर स्प्रेड करते हो, and it is not feasible. ऐसा नहीं करना चाहिए क्योंकि it's required a cost and all the stuff. So the multiplexing is going to be a solution for that. So the main line is only looking for the 6 major line. वो आगे जाके demultiplexing होते होते पूरा area cover करेंगे. These are the stuff we have. Similar type of this stuff is going to be happening in digital. So it is like that. There are 64 kbps of each channel. So we can say there are individual 24 channels are there, and each channel is containing the 64 kbps data. So वो 64 kbps multiply by that 24 when you do, it will give you the 1.544 mbps data. तो वो क्या करेगा कि देखिए कि आपकी कोई एक सोसाइटी में 24 लाइंस है, अगर आप उसका टाइम डिवीजन मल्टीप्लेक्सिंग करते हैं तो क्या करोगे? सोसाइटी के एंड पे आप एक मल्टीप्लेक्सर रखोगे, उसमें सब चैनल का डेटा होके आपको एक DS1 मिलेगा जिसका रेट क्या होगा? 1.544 mbps. नाउ अभी इतनी बहुत सारी सोसाइटी है, कितनी you can say like you can such a 24 different society you can accommodate in the second multiplexing stage. Then again we can say that one channel is 1.544 और ऐसे 24 चैनल को आप यहाँ मल्टीप्लेक्स कर रहे हो तो क्या डेटा होगा? 1.544 multiplied by 20. So it will be 6.312. Then again what you are going to do, again such it is generating a DS2 system. Such a 4 channel you have, then there are a 7 channel you have, and overall there are a main hub is there. It is only looking for the DS3, and such 7 DS3 are there, each of having the speed of 44.376 mbps, and overall it will be the 274 mbps hierarchy. So जो भी सेंट्रल सिस्टम होगा उसके पास वो 7 चैनल ही होगी DS2 वाली. Okay, उसको दूसरे किसी की चिंता नहीं, उसमें वो चैनल सब चल रही है अच्छे से, सब डेटा को मल्टीप्लेक्सिंग डीमल्टीप्लेक्सिंग हो रहा है, वही देखना. Rest of the multiplexer will do their own task according to their geographical location. Okay, so this is the digital hierarchy is also going to be there as compared to the analog hierarchy. To do the or to saving the number of cables, ultimately this all the stuff is used to save the number of cables. ठीक है, आप यहाँ पे ऐसा कह सकते हो like 274.176 divided by अगर आप 64 kbps करोगे तो इतने नंबर ऑफ यूजर्स आप यहाँ पे एकोमोडेट कर सकोगे. ठीक है, तो उतना केबल का आपका बचत हो जाएगा टू सेंड इट टू द सेंट्रल सिस्टम. आपको सिर्फ आपकी सोसाइटी तक ही उसका कनेक्शन देना है, बाकी वो आगे का पूरा इंफ्रास्ट्रक्चर. So it will be like in the first DS1 there are 24 channels are there, and it is increased to 94, 96, then 672, and at the end it's a 4042 channels. So you can say with such a DS4 system it can accommodate 4,000 channels simultaneously if you're using such hierarchy. And it will be look like this one. Now when we can say there are a first TDM, so how this 1.544 mbps will come? It will come like this. Let's say there are 24 voice channels are there. All are so voice channel in terms of analog, but to do the data time division multiplexing, what you require? Digital data. So obviously we need to convert from analog to digital. So which block I required? Pulse coded modulation or analog to digital communication, analog to digital conversion. So this pulse coded modulation will do the 8,000 sample. Its sampling rate is 8,000 sample per second, and each sample having a 8 beats. ठीक है, 8,000 सैंपल 1 सेकंड में 8,000 सैंपल हो गए, और हर एक सैंपल को आप 8 बीट से रिप्रेजेंट करोगे. सो देयर आर 2⁸, 256 quantization level are there. If you know the analog to digital conversion, it's a sampling, quantization, and encoding. सो क्वांटाइजेशन लेवल कितने हो गए 2⁸8 256 और हर एक सैंपल का 8 बीट का डेटा जनरेट हो और ऐसे 8,000 samples generate हो गए. So 8,000 samples multiplied by 8. So we can say in one channel there are 64 kbps channels. So हर एक channel 64 kbps का data generate. और ऐसे कितनी चैनल आप कंबाइन कर रहे हो 24 and you are giving an 8 kbps as an overhead bit as I have told you sampling that I can say framing bit and all the stuff. So that 8 kbps are given as a extra overhead to do that framing and stuff. So overall it is a 1.5 frame. तो जो भी DS0 से DS1 का चैनल बन रहा है 1.5 kbps का उसमें इस तरह का बैक एंड साइड there are a combination is there. Okay. Now how it is just do the stuff? It is just a type of the graphical presentation of that. Let's say how it will do the sampling. Like हो सकता है कि जो भी 24 चैनल्स है आपके पास तो हर एक बंदा तो कुछ बात कर रहा होगा कोई ऐसे म्यूट खड़ा होगा कोई किसी की गर्लफ्रेंड को आई लव यू बोलता होगा. That's the different stuff is happened. So we can say there are a pitch, amplitude, everything is different. So whenever you take a sample, what it will do? Whenever you consider the sample at the same time of the same rate, कि मैंने बोला कि अभी तीसरी सेकंड पे सैंपल लेना है तो वो क्या करेगा तीसरी सेकंड पे जो भी एम्पलीट्यूड हर एक चैनल का है उस हिसाब से जो भी एम्पलीट्यूड के सामने उसका 8 बीट बन रहा है वो 8 बीट लेके आपको यहाँ चैनल 1 की फ्रेमिंग में रख देना है. Multiplexing is doing like this one. Let's say you are identifying a period of 1 microsecond. तो पहली माइक्रोसेकंड पे 24 चैनल्स ऑल द चैनल्स में जो भी डिजिटल डेटा में जो भी एनालॉग सिग्नल है जो भी उसका एम्पलीट्यूड है पॉजिटिव नेगेटिव व्हाटएवर इट इज उसके सामने उसका कौन सा 8 बिट डिजिटल बन रहा है वो 8 बिट उठा के आपको फर्स्ट फ्रेम में एज अ चैनल बाय चैनल रख देना है. तो आपका एक फ्रेम हो जाएगा किसका जिसमें 24 चैनल होगी containing all are 8 bits. So 24 channels multiplied by each of 8 bits and having some extra framing bits. So overall it is a 193 bits are there. तो जैसे ही 1 माइक्रोसेकंड होगा तो आपका मल्टीप्लेक्सर क्या जनरेट करेगा 193 बीट्स का एक फ्रेम. देन दूसरी सेकंड में क्या होगा अगेन 193 फ्रेम का एक अलग एक पूरा बंच बनाएगा. लेकिन वो 193 बीट क्या होंगे यू कैन कंसीडर फ्रॉम दिस. ये सेकंड पे जैसे ही टाइमर हुआ 8 बीट का डेटा लिया फ्रेम में रख दिया. दूसरी सेकंड पे क्या अभी एम्पलीट्यूड है उसका डेटा लिया फ्रेम में रख. लाइकवाइज द फ्रेमिंग इज गोइंग टू बी टेकन प्लेस such type of the technique. Yes. To give the identification of the framing. Like आप फ्रेम बना रहे हो ना तो उसको भी कुछ एड्रेस दोगे. Is the first frame or for the synchronization purpose. Like दोनों साइड synchronization होना चाहिए. अभी आप कैसे make sure करोगे कि like alternative beat दे रहे हो ये फ्रेम को 1 दूसरे को 0 then 1 0 1 0. So जो रिसीव कर रहा है अगर वो पहला बीट जो है वो इसी पैटर्न में रिसीव करे 1 0 1 0 1 0 so it will get identified. Okay, all the beats are coming into the synchronous in manner. अगर वो 1 0 1 0 की जगह पे 1 0 0 1 1 0 ऐसा हो जाए तो there are something with synchronization. Ensure that synchronization it will give the alternative beat 1 0 1 0 1 0 like that. We get the synchronization. भाई 1 के बाद में नेक्स्ट फ्रेम आएगा उसका फर्स्ट बिट 0 ही होना चाहिए. उसके बाद अगर नेक्स्ट फ्रेम आता है तो उसका बिट 1 होना चाहिए. So likewise so it will be like this also like we can say whatever the E1 E2 E3 line is there. So over here it is considered like how this 1.5 for Mbps is there. Such type of the another hierarchy system is also going to be there whenever we talk about the voice channel. So there are a 30 voice channel are there as I have told you D1 D2 D3 type of the stuff. Such type of the another line multiplexer are also there which is containing not a 24 it's containing the 30 voice channel in an initial multiplexing line. Then it is further modified into the 4 times more. So we can say E2 equal to 4 even lines. Then we can say it's a 480. It means there are a 4 E2 line combining into the E3. Likewise, there are a hierarchy. So another type of the E line rate is also going to be there as compared to the D line. So D line, E line. In optical fiber, there are another SDH line. because at that time it is also doing optical multiplexing. So at that time you are having a STH line. So depend on that which type of the communication, which type of the multiplexer you are using, this type of rate multiplexing lines are. Now it's going to be happen as I have told you. There are a synchronous and statistical TDM. There are two type of the time division multiplexer we have. Statistical, it is a normal multiplexer that we have seen so far. जो हमने बोला था कि लाइक अगर कोई स्लॉट खाली है तो आपको क्या करना है, उसकी जगह पे खाली चीज रख दो. नो नीड टू ऐड एनीथिंग, कीप इट एज अ ब्लैंक. ओके, तो इसमें क्या होगा कि जो सिंक्रोनाइजेशन है वो मिसमैच नहीं होगा, और वी कैन से whatever the empty slot are there is going to be as it is, and follow the strict process. But in a statistical TDM, it is not the case. In statistical TDM, it is only the multiplex where the data is available. अगर कोई फ्रेम में डेटा नहीं है तो उसका फ्रेम की जगह पे नेक्स्ट फ्रेम का डेटा वहां पे. You can see from the second diagram, A1, B1, and line C is having no data, so it will directly give you the A1, AA1, B1, and then it is give the individual frame D1. So rather than to saving that space, अगर मैं वो blank space को save करना चाहता हूँ तो मैं क्या करूँगा, हर एक बीट के आगे मैं उसका फ्लैग लगाऊंगा कि ये डेटा किस में से आ रहा है, चैनल ए में से, दूसरा डेटा किस में से आ रहा है, चैनल बी में से. सी के पास कुछ नहीं है, so I will go to the next channel and see that next data is not from C, it is from D. So likewise the frame generated, A1 coming from A, B1 coming from B, C is not having data, so D1 coming from D. Again it will go to the next session. A1 doesn't having the data, so B2 coming from B. C is also not having data, so directly it is jumped to the D. E is having the data, so E2 from E. So likewise, whatever the empty slots are there, it is going to remove and giving the individual identity, individual frame number, and it will multiplex and create a multiplex plan. Such type of the technique is considered as a statistical TDM. It will happen when it is not like that every time all the channels are there. It is in a line. आप पूरा दिन तो टेलीफोन लाइन पे बात नहीं करोगे ना, हो सकता है कि आप जब पिकअप करो तब वो मल्टीप्लेक्सिंग में आना जरूरी है. It's such type of the statistical TDM. So whatever those empty slots are there, it will be saved. It is allocated to another channel. Okay. Next, we have the second concept of this particular chapter. Name is a spread spectrum. Now, what is a spread spectrum? In multiplexing, we are talking about all the stuff of saving the band. कैसे बैंड को सेव कर सकते हैं, कैसे मैक्सिमम नंबर ऑफ यूजर्स को हम एकोमोडेट कर सकते हैं छोटे से बैंड में. It's all technique are considered as a multiplexing. But what is a spread spectrum? Spread spectrum, it means it is expanding the band. Over here from this diagram, you can say like that, there are your input is required the small band, let's say B. You are passing it through the spreading process and your actually band is going to increase to something else, twice or more than that. Okay, why we need that? We are going to need that to provide a privacy and security. अगर आपको पता चल गया आपकी टेलीफोन लाइन में ये टेलीफोन लाइन इसी बैंड में हर वक्त ट्रांसमिट हो रही है, तो आप उसके बीच में से वो केबल निकाल के आप वहां पे टेप लगा दोगे और आप भी ऐसा फिल्टर अपने हिसाब से बना दोगे, तो यू कैन आल्सो हियर द सेम स्टफ. पॉसिबल है ना कि अगर आप मल्टीप्लेक्स कर रहे हो तो आपको पता चला कि ये टेलीफोन लाइन 1 ये बैंड में जा रहा है, टेलीफोन लाइन 2 ये बैंड में जा रहा है, तो आप वो केबल निकाल लो जमीन में से. आई एम जस्ट गिविंग द एग्जांपल एंड यू जस्ट पुट योर ओन फिल्टर. तो आप वो भी आप सुन सकते हो, जो वहां पे भेज रहे हैं वो आपको भी मिलेगा. ये सेम चीज होती होगी अगर आपने केबल टेलीविजन ऐसा एक्सपीरियंस किया हो. Whenever you having a cable television from your roof, you just remove the outer jacket of that particular coaxial cable और वहां पे आप अपना कुछ ऐसा टेप लगा दो तो वो चैनल आपके घर में भी आएगी विदाउट पेइंग एनी सब्सक्रिप्शन कॉस्ट. तो ऐसा होता था, दादागिरी करते थे CGPL वाले. मेरे घर के ऊपर से अगर 5 चैनल लाइन जा रही है तो मेरे को फ्री देना पड़ेगा, और नहीं दूंगा तो मैं ऐसे चोरी कर लूंगा. Likewise, stuff that in Rajkot that people are doing. Okay, so it has happened like if such type of this sophisticated or such a dense multiplexing are there, and if you interfere that, you can see the information. Now to prevent them, if you say like that, you don't know in which band which channel is transmitting. So at that time, it is little bit of secure. Like just tapping the stuff, you cannot get the idea. Like वो randomly जा रहा है, कभी ये band पे जाएगा, कभी दूसरे band पे जाएगा, कभी तीसरे band पे. So it is jumping. Jumping it means you are giving a multiple band. आप उसका जो 10 किलोहर्ट्ज चाहिए था उसको 100 किलोहर्ट्ज दे रहे हो और बोल रहे हो कि तू 10 किलोहर्ट्ज का जंप लगा, कभी फर्स्ट चैनल पे, कभी थर्ड चैनल पे, कभी नाइन्थ चैनल पे. So that process is considered as a spread spectrum. It is going to be explained like this one. We can say there are original signals are there. Whatever the original signal are there, you are modulating those signals, or you are converting into the high frequency of the same signal in a random manner. और वो कैसे random multiply करेगा और कैसे modulate करेगा? You are having some random frequency generator are there. You can see pseudo random code generator are there. जो भी pseudo random code generate करके देगा, लेट्स उसके पास 1 से लेके 12 तक अलग अलग कोड है, वो बोलेगा नंबर 10. तो नंबर 10 के सामने यहाँ पे फ्रीक्वेंसी टेबल में कौन सी फ्रीक्वेंसी है, वो फ्रीक्वेंसी पे उस टाइम ड्यूरेशन पे वो मॉड्यूलेट होगा. देन सेकंड pseudo random generator says that 2. तो 2 के सामने कौन सी फ्रीक्वेंसी है, दैट फ्रीक्वेंसी एंटर टू द फ्रीक्वेंसी सिंथेसाइजर और दूसरा पैकेट है वो फ्रीक्वेंसी पे जाके मॉड्यूलेट होगा. Okay, and whatever this random sequence generator is there is only known to transmitter and receiver. ये दोनों के पास ही ये डेटा है, बाकी बीच में किसी के पास ये डेटा नहीं कि कौन से random sequence से ये चीज हो रही है. So you can beat a privacy is there. ये दोनों के बीच में भी तीसरा बंदा इसको नहीं हैक कर सकता. That sort of privacy. So it will be generating the stuff like that. K beat pattern में ऐसा हो रहा है, like पहले 101. So 101 के सामने 700 किलोहर्ट्ज है, तो आपका पहला पैकेट 700 किलोहर्ट्ज में मॉड्यूलेट होगा. दूसरा 111 है, so 11 के सामने 900 किलोहर्ट्ज है, दूसरा पैकेट 900 किलोहर्ट्ज पे होगा. So likewise, whatever the K beat, whatever this random sequence pattern are there, according to that frequency responsible for doing the modulation of this. वो अलग अलग फ्रीक्वेंसी पे जाके वो डेटा मॉड्यूलेट होगा और ट्रांसफर. So it will be having a such type of the pattern is there. Like होप में फर्स्ट सेकंड पे आपका क्या होगा 700 में, दूसरे होप में 900 में, तीसरे होप में 300 में. So likewise there are hope is changing. तो अगर आप कोई भी सेकंड पे जा रहे हो और अगर आपके पास ऐसा वो जो रैंडम सीक्वेंस जनरेटर है वो आपको नहीं पता है, तो आप कभी वो इंफॉर्मेशन फैच कर ही नहीं पाओगे. क्यों? क्योंकि वो ये सेकंड पे 300 पे था, दूसरे सेकंड पे 900 पे चला जाएगा, बाद में 600 पे आ जाएगा. So you cannot detect that pattern directly. That's why it's become a more private. Okay. So to giving the privacy, giving the security, spread spectrum is required. So this type of the spread spectrum is considered as a frequency hopping spread spectrum. मतलब कि आपकी frequency hop हो रही है एक जगह से दूसरी जगह पे, and due to that hopping, your entire required spectrum is increased as much of we can say 200 to 900. So that's why frequency hopping spread spectrum. Spectrum spread हो रहा है, but किसकी वजह से? Frequency hop होने की वजह से. Likewise, okay? Understand? It will be like this one in FDM. It will be look like this one. F4 को जो frequency दी दिया वो channel F4 पे जाएगा in FDM. But if you compare it with the FHSS, it is not constant. अभी जो स्टेशन है चारों के चारों स्टेशन, it will be right now F4, F3, F2, F1. Then after it is changing, this F4 is going to modulate it with next with the F1. So you are utilizing the bandwidth, but you are setting your random sequence in such a manner that bandwidth is also utilized as well as your security is also. Next is a DSSS. Okay, so DSSS we can say like that it is having the stuff related to the direct sequence spread spectrum, and it is also synchronous. Now, direct sequence spread spectrum, it means you are giving a chip to the individual data. Let's say there are original signals, there are a specific chip is given for that communication. And how it will chip look like? It will look like this. So you are having a one, you are allocating the chip for that. And what is that? There are chip having some certain amount of data. Let's say 10, 110, 111, 00. And it is changed with respect to the different transmitter. कि भाई आपको मैंने ये चिप दिया, दूसरे बंदे को दूसरा कोई चिप दे दूंगा, तीसरे को तीसरा कोई चिप दे दूंगा. So just I need to change this beat pattern. So whenever 0 came, the same chip is going to transmit it. Whenever 0 came, it is just inverted. So 1 came, chip is going to as it is. 0 came, chip is going to inverted. So सिंपल कि भाई आपने सब्सक्रिप्शन लिया है तो आपका एक यूनिक कोड होगा कि आपको ये सीक्वेंस कोड के ऊपर से ट्रांसमिट कर रहा है और वो चिप आपके पास और मोबाइल कंपनी के पास दोनों के पास ही रहेगा, तीसरा बंदा नहीं जानता हो। तो आप उस चिप से ट्रांसमिट कर रहे हो, मैं वो चिप से रिसीव कर रहा हूँ, दूसरा बंदा कनेक्ट हो रहा है उसको अलग चिप दे दूंगा, then it will transmit with their chip, I am receiving with that chip. So likewise there is a chip is allocated, and whenever one came, how I can distinguish between this variation of 1 0. So 1 आता है तो वो chip as it is आएगी, 0 आएगा तो invert में आएगी. So whether it is a same pattern or inverted pattern, at the receiver side I can detect whether it is 1 or 0. These are the DSSS in which we are giving the individual digital sequence chip to the different station. Okay, so that's it overall in a frequency division multiplexing in spread spectrum. Any doubts so far? Anybody, any doubt from this online class? Please tell me. Any doubt, any question? Any doubt, any question? Please ask me, everybody, if you have. चलिए ठीक है. Now there are some of the important instructions related to the canvas. ये सैटरडे पे हमारा क्या है? सरप्राइज टेस्ट 1. आप कैनवास में देखिएगा, ये सैटरडे एक टाइम दिया हुआ है, सुनील सर ने भी मेल किया होगा. सरप्राइज टेस्ट 1 है, वो कैनवास में से ही आपको देना है और वो जो भी टाइम वहां पे लिखा हुआ है उतने टाइम तक ही वो टेस्ट चलेगा. वो टाइम खत्म, आपका सबमिशन रह गया है, मतलब 0 मार्क. We must be ready with the time. हम ऑब्जर्व करने के लिए होंगे नहीं होंगे, that's the different thing. We have set a timer in the canvas accordingly, starting let's say at the 11 o'clock, completing at let's say 12:15. So 12:15 से पहले वो सब क्वेश्चन नोट में लिख के आपको सबमिट स्कैन करके भी कर देने हैं. If you are failing to do that, time is over. The surprise test never going to open again. आपके 0 मार्क. Okay, so be ready with the good internet connection at good place and appear for that quiz. And it is such a 2 quiz you have. For the D2D students, we have already done the revision session in the last week, and whatever the questions are there, it is already from those revision and up to this particular chapter. तो ये चैप्टर जो हमने recorded lecture share किए थे, जो भी revision हमने किया है, वो question उसी में से ही हो गए. So you can appear. Okay. जो लोग D2D है अब तक कैनवास नहीं ज्वाइन किए हो, सुनील सर ने मेल भेजा है, आप चेक करिए. जो भी कल तक ज्वाइन हुए थे मारवाड़ी में, उन सबको सुनील सर ने मेल भेजा है. अगर आप अभी तक कैनवास में ज्वाइन नहीं हुए हो तो प्लीज वो आईडी से ज्वाइन हो जाइए. अगर आप लास्ट में बोलोगे सर मेरा कैनवास एक्टिविटी नहीं होगा, मैं क्या फर्स्ट चेक करूंगा कि मैंने आपको कैनवास ज्वाइन होने का मेल कब भेजा था. अगर आप D2D स्टूडेंट हो, लेट ज्वाइन हुए हो, तो भी हम हर वीक पे ये चेक करके सबको मेल भेजते रहते हैं, आपको भी पता होगा. अगर आपको पहले से वो मेल मिला हुआ है, मैंने क्लास में भी इतनी बार बोला हुआ है, स्टिल इफ यू हैव नॉट जॉइन्ड द कैनवास, नॉट डन एनीथिंग, वी विल कंसीडर इज दैट यू डोंट इंटरेस्टेड इन टर्म्स ऑफ पासिंग दिस DCN सब्जेक्ट. हम आपको 0-0 करके आपको आगे भेज देंगे. नेक्स्ट सेमेस्टर फिर से तैयारी करके आएंगे. So in the end, it will be not like that, sir, हमको कुछ नहीं मिला था. No, we have uploaded all the quiz, all the worksheets, surprise test 1, assignment, whatever the Cisco packet tracer task, active learning video making, सब चीजें कैनवास में सब लाइव है. अभी ओनली 3 चीजों का आपको जो अभी अब तक हमने लाइव नहीं की है, वो कौन सी है? सरप्राइज टेस्ट 2, वो जल्दी ही आपको नेक्स्ट वीक में भी मिलेगा. यूनिट टेस्ट 1 एंड यूनिट टेस्ट 2. यूनिट टेस्ट 1 भी हम ओपन बुक रखेंगे, वो एक दिन के लिए होगी, तो एक दिन के लिए वो ओपन होगी. आप आंसर सबमिट कर रहे हो, दूसरे दिन से बंद, आपको उसमें से मार्क मिल जाएंगे. और टेक होम टेस्ट है, वो ये मंथ के एंड से पहले आपको अपने टेक होम टेस्ट के पेपर मिल जाएंगे, एंड यू हैव अ टाइम अप टू द सेमेस्टर एंड टू गिव द आंसर. So we will give you the enough time, 2 to 3 week time to complete that unit test 2. So ऐसा नहीं है कि हमने लास्ट टाइम पे बोला कि ये करके आओ और हो गया. No. About the laboratory task, TC1 में अभी 8 8-9 तक हम लैब पहुंच चुके, 7-8 तक। बाकी के जो TC2 और TC3 है उसकी लैब नेक्स्ट वीक से चालू होगी, ठीक है। सो मी एंड सुनील सर इज गोइंग टू कंडक्ट दोस लैब एंड वी विल जस्ट गो विद दैट वन। जितनी भी लैब हम लोग करवाएंगे उस हिसाब से आपको सबमिशन करना होगा। सो ये लैब का इतना चीज ध्यान में रखिए। बाकी के लैब के अलावा बाकी की सब चीजें सबके लिए कॉमन है, सबको सबमिट करना है। लैब का जितना हुआ है उतना TC1 वाले कर दे। जितने लोगों का लैब अब तक नहीं हुआ है वो एक बार हमें लैब समझा दो, आपको सेमेस्टर एंड तक का टाइम मिलेगा वो लैब को सबमिट करने के लिए। डोंट वरी, डोंट हेजिटेट, वी विल गिव यू द इनफ टाइम फॉर द लेबोरेटरी। ओके, दिस आर द स्टफ। Everybody quickly write their enrollment number and name in the chat box and then they can go on. If you have a question, we have a 5 minutes to discuss with that. Yes, what is your number? TC1 26 65, 26 and 65. TC2 TC3, yes, 01. After writing your enrollment number and name, you can leave.
हेलो सर। हेलो।
બોલીએ ઓમ, બોલીએ બોલીએ ઓમ.
હા સર, D2D માં અમે કાલે એડમિશન લીધું છે તો અમારા માટે તો અલગ સેશન કે એવું કઈ હશે?
કાલે એડમિશન કન્ફર્મ થયું તમારું?
હા.
ઓકે, એના છે ને હું તમને રેકોર્ડેડ લેક્ચર આપણે જે આ બધા લીધા છે ને એનું હું તમને શેર કરું. તમે કેનવાસમાં
ઓકે.
જોઈન થઈ ગયા છો?
ના, હજી કઈ મેલ નથી આવ્યો. તમે મેલ ની વાત કરી પણ મને હજી કઈ
ઓકે
આવ્યું
ઓકે,
નથી.
કાલે અમે મોકલ્યો, કાલ કાલ બપોરે મોકલેલું, કદાચ તમારું નહીં હોય. હવે એક કામ કરો, મને મારા નંબર ઉપર તમે વોટ્સઅપ કરો ને, નંબર અહીંયા લખો
ઓકે
છો,
સર.
9033316057. આ નંબર ઉપર મને વોટ્સઅપ કરો ને, હું તમને બાકીની જે કેનવાસ જોઈન ની ડિટેલ ને બધું મોકલું ને
હા
વિડીયો ક્યાંથી તમને રેકોર્ડેડ મળશે એની પણ હું માહિતી તમને આપું. ને આ નંબર પર
હા.
વોટ્સઅપ કરો થોડી વારમાં.
ઓકે.
મારે બી મેલ નથી આવ્યો.
એટલે ભક્તિબેન, તમે ક્યારે જોઈન થયા મારવાડીમાં?
15 ડેઝ થયા સર.
15 ડેઝ થઈ ગયા. મેલ આવ્યો હોવો જોઈએ બેન. આપણે કાલે જ સુનિલ સાહેબે મોકલેલો બધાને કેનવાસ જોઈનિંગ નો.
સર આઈ વિલ
મારવાડી નો આઈડી યુઝ કરો છો તમે?
યસ
Use your check your Marwadi University ID, whatever your name and surname, then GR number @Marwadi University. આવું ID મળ્યું હશે એ મેલ ચેક કરો, એની અંદર બધાને કેનવાસ જોઈનિંગ નો મેલ આવી ગયો હશે. ના આવ્યો હોય તો છતાં પણ તમે મને આ નંબર ઉપર મેસેજ કરો, હું જોઈનિંગ માટેની પ્રોસેસ કરાવી દઉં. બરોબર? હાલો, ઓકે ભક્તિ.
હા સર મેં ચેક કર્યું છે બટ નથી આવ્યો મેલ તો.
હું જોડ ચાલો મને મેસેજ કરો ને, હું એમાં તમને અપાવું તો એમાંથી જોઈન થઈ જાવ, કોઈ વાત નહીં. Any further doubt, anyone?
નંબર
9033316057. 9033316057. Okay. Bye bye. I will just send you the detail. Okay. First minute.